Let's continue with the second subtopic, which is 9.2 Discrete Random Variables. At the end of this subtopic, you should be able to construct probability distribution table and probability distribution function. You should be able to find the cumulative distribution function, find probabilities from probability distribution table or function, as well as find probabilities from cumulative distribution function. And lastly, you should be able to find the expectation and variance of discrete random variables. What is the meaning of probability distribution? The probability distribution of a discrete random variable lists all the possible values that the random variable can assume and also their corresponding probabilities. Say, for example, it is given to us that x is a discrete random variable. Hence, we can write x as x1, x2, x3, x4, and so on until xk. Therefore, the probability of x can be written as px equal to x, which is equal to px equal to x1, px equal to x2, and so on until it reaches px equal to xk. As you can see, this probability of x will correspond to our random variable x. We start with x1. That's why the first probability of x is px equal to x1. And then, when x equal to x2, the probability is px equal to x2, and so on. Let's start with 9.2a, probability distribution function, or px equal to x. In order to show that it is a probability distribution function, or whenever you need to find unknown variables such as a, b, or c, this is the formula that you can use, which is the summation of px equal to xi from I equal to 1 until k is always equal to 1. Probability distribution function, or px equal to x, can be represented in three different forms. The first one is as a table, or we can call it as probability distribution table. Let's recall back. If x is a discrete random variable, therefore we can list down x as x1, x2 until xk, where all these values are all the possible values that the random variable x can assume. Hence, for the probability distribution table, we're gonna have two rows. The first row is where you list down all your values for your random variable x. And in the second row here, we're gonna put all the corresponding probabilities for each x. That's why, if we have x1, the probability is px equal to x, and so on. Px equal to x can also be represented as a piecewise function, or we can call it as probability distribution function. To write a piecewise function, just use the table that you have made beforehand. On the right hand side, you're gonna list down all the values of your random variable x. And on the left hand side here, you're gonna list down all the corresponding probabilities for x1, x2 until xk. So, when x is equal to x1, the probability is px equal to x1. That's why when x is equal to x1, px is equal to x1. When your x is equal to x2, the probability is px equal to x2. So, x equal to x2, hence px equal to x2 here. Until we reach when x equal to xk, the probability is px equal to xk. Px equal to x can also be represented as a graph. And for this graph, we only need two things. The first one is the values of the random variable x, and the second one is the corresponding probabilities of your random variable x. For the x-axis, we're gonna put all the values of our random variable, starting from x1, x2, until you reach xk. And for the y-axis, it's gonna be our probability. Say for example, when x equal to x1, the probability is px equal to x1, and let's say px equal to x1 is here. So what you're gonna do is that you're just gonna draw a straight line at x equal to x1 until it reach px equal to x1. When x equal to x2, the probability is px equal to x2. Say for example, px equal to x2 is somewhere here. Therefore, you're gonna draw a straight line going up until it reaches px equal to x2. Repeat the same process for the rest of the probabilities. Hence, your graph will look like something like this. Also, the mode of a discrete random variable is the value of x when its probability px equal to x is the highest.